killed everyone. Many cancers are enhanced by folic acid. Not all, because you know there's 1,000 different types of cancers. There's not one cancer. But in this case, the people all die faster. You gotta be careful of what you do. Okay, that was a long time ago though. That's types of media. Which one? Rickettsia. Rickettsia. The other one's chlamydia, and then viruses. All right. Yes, it does have a similar name, but that would be a logical extension, but it doesn't quite do that. Okay? Now, coming to the next one.
Is the differential media, the previous examples, is this just an example page here?
That's the ones I put pictures up of. Okay, that's the blood agar plate, and that's the microbiology plate. And that's just think of differential media to tell the difference. Okay, selective to try to grow one, and yes, they can grow one. And that's it. See, I need to do here. I'm not sure I'm going to throw it. Okay. Briefly, for about 3 minutes, I'm going to go over how you can measure. Now I want to do microbial growth first. Microbial growth. And then when we're on board, I'll probably have to finish just about 5 minutes up in the next class period. Bacteria reproduce by what? Binary fission. What does that mean? It means 1 to 2, 2 to 4, 4 to 8, 8 to 16. Do you see? Massive increase. If we had our savings account like this,
It'd be awesome.
we'd be set. We would never, ever have to work.
Ever.
Because wouldn't that be nice if I was working for an old age? Okay? Bacteria do not have mitosis, meiosis, spindles, centrioles, any of it. It's going to sound too simple. What they do, since they have no membrane but everything else, they don't have a nucleus either, right, per se. They attach the bacterial chromosome straight onto the cell membrane. And they have your regular shaped bacterium. They'll duplicate their chromosome, and they'll have 2 attached to the cell membrane, and the cell elongates. When the cell elongates, what's it doing to the chromosome? It's not straight, it's pulling it out to 2 different opposite sides. One goes left, one goes right. But there's really left, right, go up and down, no anything. Then it will form a cell wall down to the center of the elongated cell. Close. Technically, that's called a septum, and you would get 2 separate cells. You can either get 2 completely separate cells, like E. coli, or you can have a little bit of a connection there with the cell wall, and you can get your arrangements, like your strepto chains, your staphylococci chains, or staph chains, because they're just a little bit still connected and they didn't completely separate. That's it in a nutshell. Better moving over to other things. Next thing I'm going to go to, and this is the difference between arithmetic and logarithmic. Logarithmic is the same type of word I'm using for exponential. 1, 2, 3, 4, 5, that's not a massive increase. This is logarithmic or exponential. If you tried to graph this on a regular 1-to-1 graph paper, arithmetic, you could have the paper here and you'd still be drawing the top of your numbers clear over here. So they go to a special paper, and you'll really be taught this in lab because we're going to do it, called semi-logarithmic paper, semi-log paper. And the way semi-log works at the beginning, which will give us a depth later, is you squish it. Squish down the numbers. You have a section that would have those bacteria that are at times, we'll say 5 times 10 to the third. What is 10 to the third? 3 means 3 zeros. 5 times 1,000. So all these bacteria would be in the thousands. The next section above will be, say, 4 times 10 to the fourth. What is that? 10,000. All those bacteria are in the 10,000 numbers. Then the one above that may be times 10 to the fifth, bacteria in the what? 100,000s. But you don't write 100,000. You put 10 to the third, 10 to the fourth, 10 to the fifth. scientific notation. That's not scientific notation, that's exponents. The other significant figures are in scientific notation. Okay? That's what you have to do to plot a bacterial growth curve. I'm going to show you one of those in just a minute. But first I want to show you a very simple calculation. What if you want to tell the number of cells in a population? Number of cells in a population. You take the original number of cells, you multiply it times 2 to the n. Okay, first, n is an exponent. So if n in an example was 3, how many times would you multiply 2 by a cell? 3 times. 2 times 2 times 2. If n was 5, how many times would you multiply 2 by a cell? 5 times. You know this because you already taught you this. Why 2? Binary fission. Everything doubles. 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 That's why 2.
Is that like when you get like pregnant, all those hormones and stuff, they double and triple and all that stuff?
That's probably a little bit different than bacteria because this is straight line, but they do increase. And by the way, if you have twins, the hormones increase faster than in a single pregnancy. Because you've got to mature those twins because they usually deliver faster, and you've got to get their lungs ready for air, usually sooner than a regular pregnancy. So the hormones in a twin or triplet or whatever, through the roof. Okay, because you want that child to mature. The body's trying to get that child to mature because they're often born early.
So what is with everything in your body tripling and doubling?
This is bacteria.
Why
That's
does it? But is it because of your body that makes it triple or double, or?
I don't quite know. I know that they increase. I don't know their exact levels of increase. I know it's more for twins versus single. And that comes, remember you have to have those proteins that develop in the lungs before the child is able to breathe air.
No, I mean, but like the bacteria, how come bacteria always double?
For the bacteria,
Yeah. Why do they have to?
that's observation. That's what they do. We don't know why. They probably don't know why. That's just what they do. That's like, well, we know grass is green because it reflects the wavelength that's green. But, it's just the observation. They do 2 to 4 to 4 to 8 to 8 to 16.
So
We
they
look
never
at them,
get
that's
odd
what they're
numbers.
doing. Huh?
They never get odd numbers then.
No odd numbers. Always 1 to 2 or 2 to 4. That's a good point. No odd numbers. Okay, let's give an example here. Please keep talking to me. We're always trying to talk about anything that helps with learning. Let's say you start with 3 cells. That's ridiculous. You don't start with 3 cells. You can start with 1,000, you can start with 10,000, but this is an example. Okay, plug it in, 3 cells. Well, let's do some pre-teaching before I come to this. E. coli reproduces, doubles its number every 20 minutes. If E. coli was sitting on your desk right now and you've been sitting here for an hour, how many times has it doubled on your desk? 3 times, because there are how many 20s in 60 minutes? 3. Well, this example has 6 hours. So how many times has it doubled its number? How many 20s are there in 2 hours? 20 plus 20 plus 26. So n is equal to 6 here. N is equal to 6. Plug the numbers in. You have 3, you have 2 to the 6, you multiply 2 out, 2 out, 2 out, 2 out. You get 64. You have 192 cells. This is usually per meal. In 2 hours if you start with 3. And it's just equal. Okay.
Start from the
I think you were saying,
the 3 cells.
I thought you said 8.
3 cells.
8 hours.
Yeah, you said
Okay.
6 hours.
6 hours. Yeah,
6 hours. Did I say 8? I meant
No, you
6.
said 6 hours instead of 2.
No, I'll give you an example first to get you the idea.
Oh, okay.
Okay,
That's what
so I'm
we're
saying if it grew 1 hour, not here,
Okay.
then it would have how many doublings in 1 hour? That's not here yet, 3. But if it went 2 hours, which is 120, how many times would it double? 6. So does that make sense?
Yeah.
Plug the numbers. I just want to teach you 1 hour before I went to 2 hours. That's all I'm trying to do. Okay? 6 is n is generation time, which means how long it takes to double. Plug the numbers in. You've got it.
Where did the 64 come from?
64 is you
Two to the
take 2
six.
to the 6. You take 2 times itself 6 times. 2 times 2 times 2 times 2 times 2 times 2. And then it comes out to be 64. Now ask me questions because you're supposed to. Does this make sense?
Okay, so then once we do that, that's when you get it, and then you do 3 times the 64, and that gives you the answer. Because that's 3 cells times 64.
Yes, 3 cells times 64, because 64 is 2 to the 6 if you're doing your
So
math.
the 64 hours in the 3 cells.
No, 64 is just going to give you your cells. You've already done your hours by figuring out what 6 was.
Okay.
Yeah, that's already been done to know that in 2 hours you have 6 sets of 20 minutes. 6 sets of 20 minutes. That's where that came from. Keep asking me questions because you're supposed to. Does that make sense? Okay. That's what you do. Massive increases. The only thing that stops them, oh God, I'm going to do this. I'm going to switch to something. I'm going to do it. Nope, I'm going to go for it. I will go over it again. Like to it at the end, but I'm going to go for this. Massive numbers in a short time. You will get this again, but I want to show this to you now. I've got 2 minutes, so I'm going to take it. Okay? All right. On my head. The bacterial growth curve. I will always take time for questions, no matter what it does to it. This is on semi-log paper how a bacterial growth curve will look. This is plotting the cell numbers. This is lag phase. This is log phase. This is stationary. This is death. Here, lag phase, something is happening. And I'm going to do this again at the beginning of next time. The cells are not quiet. They're actually producing new enzymes and new transport proteins so they can grow on a new food. Maybe they grew on glycerol here, but you dumped it into lactose. They don't have the right enzymes. They don't have the right transport proteins to bring food in. So they have to turn off part of their DNA and turn on the other part for the enzymes and transport proteins they need. Once they produce the enzymes and transport proteins they need, they go through their maximum growth as up to the level the chromosomal DNA allows. Maximum. This is your binary fission flying here. Maximum increase. Massive number of cells produced. They're going to start running out of food. They're going to start producing their own pollution or toxins. It's going to slow them down.
In log?
No, log maximum growth. Then they're going to start running out of food. They're going to start having pollution. In stationary, about the same amount born as die. Then you're really running out of food, and you're really building up toxins. More cells die than are produced. You never get to 0. There's always 1 or 2 alive in there.
So there's something that happens in the stationary that I should recommend?
About 12 years, you're starting to run out of food, starting to get pollution, but you don't have it up to the level of death. You want to hit with penicillin, you hit in only one area. One of these. Spores are only produced in 2 areas. Think about it. Where will the spores be produced?
Stationary.
Spores produce, what are spores? Survival. Survival. So they're running out of food. Late stationary, early death. Okay? Where would you hit with penicillin? Penicillin affects, no. Penicillin affects organisms that are growing fast.
Like log.
Law.
I'm sorry, can you